Okay, my friends, what does this giant sinkhole have to do with the giant earthquake that just happened in Russia? This is on one side of Russia, and the earthquake happened on the other side of Russia. This is related. Okay, as is my standard operating procedure, let's cut to the chase. This exploded outwards, and these are literally like layers of tissue. And you say, whoa, layers of tissue, why? Because this was, I believe, an alveoli of the lung, a big cavity in a lung. And these little balls are where the air infuses into the lung and so forth. This was, at one point, primarily tubing. And you breathe in and breathe out. And these layers, you can see them. Look at how it's folded back here. Just observe. Look at this. It's like a piece of paper. And there's more than one layer. It's a layer, layer, layer. And that's how membranes are. This is a membrane right here. Everything has a membrane around it, and your lungs have membranes around it too. And this is a mudfossil lung that has been completely eroded of its pleura, which is the outside coating, and you can see the holes of the alveoli, and this would be one. Now that one's probably a big one. There's big ones and there's small ones, and they're loaded with blood. There's a ton of blood in your lungs, a ton of blood, but there's a ton of air spaces. You have to have air spaces. The blood circulates all around there. You see it? All that red stuff, or orangish looking, that's all blood. And there's holes going through there, millions, literally millions of holes. And this is just one of the bigger ones, and it built up in gases and popped. And you say, well, why would it build up in gases? Well, anytime something decomposes and it's biological, it will give off gases. You're just laying on the counter, and just give out, ooh, that stinks. Well, if you put it in a rubber bag, a plastic bag, sealed it up, put it on a counter, the bag's going to go like that. That's just this right there. Now, this was the permafrost. This was the tundra that sealed it, and it's been very, very well frozen for a very, very long time. I think that I can't attest to 100%, but it's getting soft. Let's just go with that. And as the softer it gets, the more it explodes. Now, I did actually talk to the Russians about this when this happened. And a couple weeks later, they had 13 new baby craters popped up. And they're going to be everywhere. And I know there's getting more and more and more as they go along. Because a lung is just like that. There's just nothing but holes and craters in it. And I'm sure that's a crater from a lung. I'd be very, very surprised. Well, I would never believe it. If you could try to convince me that that's not what it is, you're going to have a hard time. Okay, so you say, well, what would a lung look like if all that stuff was here? Well, here it is. That's a lung. That's been DNA tested, and that is human. Homo sapien. You see how flat that is? All my stuff basically died in the Great Dying, the Great Flood. All right, and that's what caused this stuff to transition and become mud fossils, because it was laying in the mud. Now that one there has still all of its pleura on here. That's this fabric. Hold on one second. All right, don't forget, this stuff here, there's layers and layers, and it was totally wrapped around this lung at one time. And in my microscope, I have this lung that I had DNA tested. It's just had red blood running out of there. I drilled into it to get some deeper stuff, and it's just solid red blood. And this is what fascia is. It's a fabric. There's all these little blocky looking things. It's straps. And the black balls are the anchors. They anchor to those straps. I can come right down close and show you very close. I gotta turn the lights down. This takes a while. You see it? These are little straps and gooey stuff. It's like a gooey, they call it pleura. If you look it up, it's just a membrane that surrounds the lung. Now, that one there is this lung right here. Hold on. That's this lung. Now, I have one here that has 50-50. It's got half of the pleura worn off, and it's got the lungs sticking out. You see it? That's the actual lung. And this is the pleura. It's been pushed away. See how thick that stuff is? So now we'll take a look at this versus the pleura. It's going to be the same pleura as like this one down here, but underneath is where the lung alveoli are. And there's little bitty tiny holes in there. When you get down to the microscopic size of oxygen, basically, you're way down there. All right, I got to put some water on here so it'll show up the things. But that right there is the pleura. It's just been pushed apart, ripped apart. But up here is the red blood. This is red. Right under here is that. Those are all alveoli. Those little tiny dots. And this is all the fabric. Now this has this little thing here. You see the tab right there? See the tab? They all have that. They lock them in. The lungs have it. See this one? The same thing. They have that lock in there. Actually, this is the lock. This sometimes they have two, I don't know, but I think that's the lock on this side that straps it into the body so that it doesn't go floating around. Now we're going to look at this in a microscope. But I got to put some water on it, let it settle for a few minutes. You see how flat it is on the back? Same thing. Died in the flood, boiled off all the flesh, and the organs stayed intact because of the fascia. I originally called mud fossils fascia facilitated fossilization because it's the fascia. Whatever's inside the fascia stays okay. The fluids can run in and out. That's what fascia does. It lets things in and lets things out. But it protects the contents. The flesh just turned into mud. And the bones just turned into little stones and, little bits and pieces of this and that. But the organs stayed very, very well. All right, there's the lung in the microscope. This is the red bloody part. And I got to put more water on it. It sucks water up just like that. And I'm going to show you, I think I can make it turn back into blood. So that's what we're looking at. And here it is up in the microscope. See my finger right there? That's what we're looking at, what I was just pointing at. Now let me come up close to it. I'm going to see if I can turn this back into blood. Red blood rehydrates almost instantly. All right, so I have my little scribe. I'm going to put some water on here. And then I'm going to scratch it up a little bit. All right, you see that water squirting on there? That's a little hole right there. There's holes everywhere. Watch this. Look, it's turned right back into blood. I'm not scratching hard, it's just blood. It's drying up almost instantly. The hemoglobin, the red blood, that's the artery blood. Now the black blood is different. That turns hard and it does not rehydrate. The red rehydrates, and there it is. Now that's some strappy stuff that was on the outside, but primarily everything's gone and we're into the alveoli right here. All right, this is all what I could consider alveoli. Now, if we go off of that, we're going to end up in the pleura. All right, see how quick that's drying up? Now, I'm going to go to the edge where it turns from the rip spot and ends up going back to, hold on, let me just set it up. All right, here's the fascia where it just settled in and wasn't all torn up. And it's just fascia, or pleura actually. There it is right there. And there's a little fabricy stuff, and it's stretchy and gooey, and your lungs do this all day, and that's what it does. sucks up that water fast. Now, at one time, this could have just turned into mud. Because like I showed you, I can just make this turn back into mud instantly by just scratching it up a little bit. Watch right here. It's just, I could do this all day long. I have other ones. It looked like this rock just started bleeding. I mean, literally, I thought this damn thing was going to start bleeding. I was going to put a tourniquet on it. You see all these little strappy looking things in there? Those are fibers. This is fabric. It's very, very, very durable, and it's very well made, and it lasts many years, I hope. Okay, so I say I have a pretty good selection of lungs. I have one completely stripped, right down to where the blood is, completely void and empty. I have one completely perfect, just so you could almost transplant that thing, it's so perfect. I have one, it's a 50-50, that's where the water was. It's just been all eroded away, but still flat because basically it all died in that great flood. And then I have this one, which you say, oh, Roger, that's not a lung. And I say, oh, yes, it is. There's the lung, right there. That's this stuff right here. And that's the pleura. Just eroded away down to where it's just getting stripped completely off, and we're at this level right here. So the pleura on this is basically gone, turned into mud. There's that strap thing that I talk about at the bottom. They have that little locks it into the body. This is the lung inside here, which is just nothing more than tiny holes, and there's the guy's back. You see the back, the bones that are in there? You almost never, ever, ever find bones. The only reason they're there is because they got impacted in the mud when he died, just like this. And at one point, everything got eroded away, and the little rivulets came off of here and left this muddy-looking stuff. But that, my friends, erosion of body parts is the origin of mud. All right, don't forget, membranes don't come in just one sheet. They come in multiple layers, and I mean a lot of them. You see this? That's a membrane. You see that up there? That's like, membranes are what they call bilipid phosphates. They have a phosphate layer up here and down here, which is the phosphorus. And then in between, they have a fluid-filled section in here, and that's it. So this was a membrane, and in us, you can see right through that. If you look at that, it's just nothing. Now, so this is from a very big creature. I don't know what, but it certainly shows the type of things that I'm talking about. You have membranes, and that thing just popped right open. Now, the Earth is literally popping. Now, this has been going on. I think I mentioned, I actually spoke to the Russian people about this. They contacted me, and I made my claims, and I don't know what they thought, but this far exceeds my expectations. If you can see, these are straps. They're little straps. I don't know if you can see that or not. But like that's a little block there, another one over here, another one over here, another one over here. And I would have never noticed that ever, except for when I was examining the Russian sinkholes. Now, this is inside the lung, and the Russian ones are lungs too. Well, let me see if I can find that. You see, this is where all the air flows through your lung. All these little holes and everything. And in the Russian one, all these little tiny air holes in here turned out to be blobs of snow because the moisture runs through there, and normally it would evaporate or whatever. It just turned into balls of snow. Here are just like little balls of liquid. Now, I showed you the straps up here. You see it? I don't know if you can see that or not. These are straps. When I saw that, I almost fell over. And I'll show you why. And there's no question 100% certainty that this is a lung. There's no question it can be tested. Look at all that coloration from the blood, and the black is the vein blood, the red is the artery blood. And that's just in this lung that I'm just showing you, and it has those straps. Where do you see where the straps are? This is too much. My mind is just ready to explode. I just never expected this. I just showed you the straps in this. Look at this. I was getting pictures, well, they're everywhere. You can find them anywhere, of the sinkholes in Russia. But specifically, when it exploded, I was getting these. And I could see that was twisted out. It was blown out. That's like, it was flat at one time and it just came out like that. These are plates of membranes. And then I saw all the little holes here. And well, they're just, they call them dragon balls. They come out in these little, those were air filtered in there, so you could absorb it. So I knew what it was. And then they sent me or I saw them somewhere, whatever. I saw this one. And I said, you can't see anything. There's all snow all over. You can't see anything. And then one day, just recently, I looked at this and I started looking. I said, these are straps. These are literally straps coming up here. Can you see those? Those are literally straps. It's just exactly what I just showed you in the lung I just have here. Those are straps. That was a lung. And all those balls are where the air would have come in and the fluids move into them because they're little tubes. They're just little tubes. And the water tries to run in and out of them and it froze up, and then that's why you got all those balls. Okay, I've told this story many times, but if you haven't heard it, I'm going to do it again. The reason I got involved with this sinkhole thing in Russia was because I saw on TV, it was one of those science shows, Nova. And there was a Japanese guy on there talking about how sinkholes form and erosion and this and that. And I could, I didn't agree, so I got a hold of him. A very, very nice guy, nice guy. And the next thing I know, he gets back to me and he says, the Russians want to talk to you. And I said, about what? He's about the sinkholes. And it was this right here. Now, I don't remember when it was actually, but I think it was before 2015 or in that area, because this goes back to 2014, July 2014. And they hit this like a SWAT team trying to figure it out. And I actually talked to a Russian guy. He's a very nice guy. Spoke good English. And very nice, respectful, very, and I told him, it's biology, it's decomposing, and you got methane gases exploding. And, what he thought, I don't know. That was the last contact I had with him about that. But it's what it was. Okay, so using Google Earth, they went up and they found it. They're everywhere. It says examination using satellite images helped the Russian experts understand that the craters are more widespread, with one large hole surrounded by as many as 20 mini craters. It's like this, a big hole and then a bunch of little ones around it. And that's what happened right after the big one went. A couple weeks later, they had another, I forget what it was, 32 baby holes popped up, something like that was the thing. And I don't know who I actually talked to. It might have been this guy right here. A very, very nice guy. Their science is top shelf, and they have open minds. I was very, very surprised. But they did an urgent investigation, and they did. To contact me I thought it was kind of exceptional. But I did have the evidence, and can anybody accept the evidence when it's presented? And I'm showing the stuff. You can't deny what I just showed you, or what I will show you. Not a thing doesn't fit. It's spectacular. It's concerning. It's scary, but it is what it is. All right, so why they're popping is because the methanes that are trapped in there, that as biology decomposes, it creates methane gas. It remains stable, almost like ice, and frozen at certain temperatures, but as the permafrost warms, the internal strength decreases. It may be less able to withhold the buildup of subsurface gases, and thus a release of methane is possible, and they're exploding all over. Just go to Google Earth and look at that area, and I'm going to show you why I say it's related to another area, and we'll examine that right now. All right, here's the relation. This is the Yamal Peninsula. This is what originally they were looking at, this gigantic crater exploding, as I showed you. Look at this. You see those different colors? Those different colors represent different chemistry, different transition metals. And I see a lot of the greens and the lighter colored greens, and then they go into the dark blues, and sometimes you can get a yellow, all kinds of different colors. And I'm pretty darn sure that we are talking about this stuff right here. This whole area is just saturated with these little pools. Look at these kind of river systems. You know, I know, I've seen these hundreds and hundreds of times. I know what they are. Well, look at that. Isn't that something? So why do I say that this, which is way off to one side of Russia, is related to the earthquakes in Kamchatka? Well, let's see if I can draw that, you know, out of this mess of things. And I can. All right, let me focus in on it. Hold on. All right, look at this carefully. We were way over here in Yamal area where they had that gas explosion, and the sinkholes are all showing up. Now we go way over here, Kamchatka. I showed you all of those little holes. Look at this now. When you see something like this, that's not accidental. They say, oh, they're just shifting their plate tectonics and this and that. No, it's not. That is biology, my friends. And when it comes right down here to Kamchatka, down in this area, they just had that gigantic earthquake. This stuff is rotting. And I think it probably was right about over here. I don't know. I would have to really see into their detailed seismic data. But when I see something like this, that didn't rise up out of there for no reason whatsoever. Now, I don't know how much pressure's inside there, but it looks to me like there's some compression coming upwards. Same thing here. That's not a sinkhole. That's elevation 2624, and over here it's 172. There's a couple thousand meters. That's a lot. These are pretty high, and what it is, you got pressure. That's it is. There's no question about it. It's building up more and more pressure. As it does, something's going to give. And when it does, it could blow up. It could just shoot right out of there and explosively go crazy. Or it could just belch. But this is membranes around here. And it was out here, the whole thing. But, oh, I didn't show you the lakes. Hold on, let me find the lakes. All right, let's just do it this way. This is Kamchatka. This is where they had the big, terrible earthquake. Look at this. People aren't living here. And what these shapes are and how they got here and all that stuff, in my mind, it's got to be biology. Nobody's out here cutting the grass. Things are splitting apart, it looks like to me. That's, of course, a river. Well, look at all the colors of blood and transition metals and coming out of this big pimple-looking thing up here. Hold on. Look at this. This is something that is, you see the bulge around it? That's all part of this, whatever it is. And it's coming up like this, and then it comes way up here. Way up at the top, it's like 2758 meters. And down here at the bottom, it's 49 meters. Well, there's 2,700 meters up there. That's a lot. That's, well, it's a lot. Close enough. Now, so what are we looking at here? Look at this. If you're into biology, you're a chemist or an anatomist, a biologist, you look at that, you say it's transition metals. These are different blood colors that are running out of this, whatever it is, and that right there is artery blood. It's an artery. It's just flowing out of there. Now, as pressure builds, it's been flowing. I would say that's just, maybe it's new flows. I don't know. I have no idea. But it's coming down to here, and these are coming over to here, and look at this. It's more transition metal colors. And they separate according to specific gravity. Certain ones are going to be heavier than other ones, and they're going to flow from different areas. You see down here, look. That's not natural. I mean, well, it is natural, but it's not what you expect. Somebody's out here working this. Looks like to me. Although I don't see anybody driving in. Well, there's some roads. Yeah. Somebody's working now. But look at that. That's blood. That's why they're out here growing. They're in the middle of a bunch of blood, which is the best fertilizer you can get. So this is what I'm saying. This is biology, and it's warming up and exploding. That's what it has to do. This earthquake here is the same as Yamal. And I don't know what you can do about it. I don't think there's anything that can be done at this point. But it is what it is, and the best thing we could possibly do is not make the atmosphere expand. But that's a hard thing, because every time you burn something, it makes more and more gases. And they say, oh, they'll drift into space. No, absolutely not. That stuff stays. It's being pushed into our atmosphere by the outside atmosphere. There's no vacuum in space, none whatsoever. That's ridiculous. We are being impacted by things out there, creating a zone that almost is impenetrable. It's, you know, obviously rockets and all that stuff can go through there. You can get through there, but it's not going to go flying into space, all these little particles. No, absolutely not. They're being pushed in, and that creates the ionosphere, and that creates a temperature in the ionosphere of over 3,000 degrees. Way out there, over 3,000 degrees. Nobody can explain it. Well, I know why it's doing it. Because it's scrubbing through the non-vacuum of space. Not a big, hard thing to figure out. All right, so here we got Kamchatka Peninsula. This is nothing more than biology. And right here is why it's exactly the same as over in Yamal. And they're gonna, I would focus in on this area to look if this was the area seismically that was the problem. Look at this. Same stuff is over there in the other side of Russia. Look at this. Look at that. That's why. This is nothing more than biology. It's and the hotter it gets, the warmer it gets, the more it decomposes. The more it decomposes, the more shifting, all kinds of things can happen. But it's all related to global warming and the fact that everything is biology and they just never understood it. Look at that. Look at this. Isn't that stunning? Yeah, if I was them over there in Russia, I'd focus in on this area right here and see well, there's certain things you can, there's not much you can do, I'll be honest with you, other than get some data. And you could get the chemistry of what's in these pools. I don't know exactly why, but every time you see a different color, even a tiniest little different color, it's going to be some little different chemistry. There's going to be a different enzyme in there. There's going to be a different transition metal. We could learn something from that. I mean, it's stunning, stunning, stunning. Look, purple. So we could get some chemistry from all these different things. And like I say, I don't know what you'd find from the chemistry, but something's going to be different. You see this blue and this green and this purple and yikes. Different colored greens. There's a lot. Green is a big color. And all kinds of different colored greens. So anyway, we could get chemistry. See about the water temperatures, even in like the temperature is this, what about this, what about that, I don't know why. It's just something to do. You know, if you're out there, you might as well do it. You know, in the rate of change in the tundra depth, the ice, how is it still frozen? It looks to me like there's almost no protection there anymore. I don't know how much there was before, but it doesn't look like there's much now. And is it getting soft? Is it, you know, and what about the air and the gases that are in this regional area? Are they giving off sulfur gases and so forth, which is the breakdown of phospholipid membranes? Look at this stuff. Look at that. So that's, you know, obviously there's, whenever you have liquid, you're going to have a little bit of shifting maybe. You know, there's a lot of liquid in there. It comes all the way down here too. Now for some reason there's a lot of liquid collected in that area. What body part, I don't know. But it is a body part. And you just keep coming down, it just keeps same stuff. So, you know, I'd make sure I was prepared to have a good solid foundation or whatever you're living on. You know, I mean, it's going to shake. Something's going to keep shaking here. The more the earth warms up, the more it's going to happen. There is no turning that around. Not now. Nothing I can think of. If you can, I'd like to hear it. This is just too much of a problem. It's too much to... Well, do a little research. Look up methane gas releases, and, you know, that's the big #1 thing right now, is they're worried about methane gas releases. I don't blame them, because the earth is starting to decompose, creating the gases. The gases cannot get out. That's the key. They cannot get out. All right, you can look it up. So the methane gases are just bubbling. And it's getting very, very serious. And methane traps much more heat than carbon dioxide. So it's a terrible greenhouse gas, and you can't stop it. That's all those things are producing gallons and belching methanes. You see that? It's exactly the same as this. If you cut that on an angle, you'd see they come down, they stop here, then some more come down, and they come down in sheets. That's what membranes are. You see how many sheets of membranes are in there? That's not this, I mean, it's just ridiculous. And that's how many layers of membrane there are in the human, well, in anybody, creature's body. This is not necessarily human, I don't know what it is. This is up in that Kamchatka area. And again, this is the kind of stuff you have. It's biology. It's nothing I made, it just happens. It's fascinating to explore and think about and look at the things and try to figure out, you know, if the leg bone is attached to the hip bone, that type of thing. Now look at this. Look at these colored legs. These are different. Now, so what do we got? What does that mean? Why are these colored ones different? Oddball, look at them. Pink and yellowish and real light green. Orange. Purple. Look at that. Whew. Blow your eyeballs out. What is the chemistry? I don't know. What I can tell you is these are exuding methanes with a vigor. And they know this. I don't know what the thought process is on how to handle it. And again, I don't like to be negative, but I certainly can't see a way that it can be dealt with. They're mining it. They know this stuff is here, and this is biological stuff. The biology of a creature's body concentrates certain things in certain places. Just the way it works. Your heart is saturated with blood. Your lungs saturated with blood and basalts, because the basalt is a structural rubbery stuff, and when it turns hard, it turns hard, and the flesh erodes into mud. It just erodes into mud. I can make mud all day long here. And tendons are primarily basalts. The connective tissue is what they build with in the ancient days. And but it's all chemistry. The whole thing is chemistry. And again, this is on one side of Russia. The other one's way over on the other side of Russia. But they're connected. Everything is biology, my friends. It's up to you to take that or leave that. To me, it does not matter. I have figured this out to my satisfaction. And don't forget, everybody's telling me, Scorpzilla's tail. Well, it's close. And I started to go back to look at this. Scorpzilla, just in case you don't know, he's a gigantic scorpionzilla. Here's his head, runs all the way up the west coast, and here's his tail, and here's his pincher, stinger, whatever you call it. Here's what it is. His beard here is Crowley Lake columns, those big white columns. Here's his eyeball. It's an audible looking thing, and yes, here's his shoulder coming way up over the top here. Mount Spur up here is his rectum. I'm not kidding. And these creatures, you know, dragons and lizards and all that stuff, they're like birds. They have a cloaca, and the two come together, the feces and the urine, and and that's what this is. The Mount Spur is a cloaca. Now, and that stops here. Now, then you get into the same. All right, I'm not trying to scare anybody, but they're talking about fears of huge volcanoes set to erupt amid spike in earthquakes. It's the spike in global temperatures, leaving major U.S. cities on edge. They don't, you know, what's it going to do? Is there enough seismic activity to be dangerous? Well, this is actually Mount Spur in Alaska, and this is way up there towards by the Aleutian chain, and I have shown this many times. I know exactly what it is, and it's kind of dangerous, yes.